This video continues the previous video, which was about the identities and inverses of matrices and how we go about using them. This video will focus on solving equations that use those inverses. So, to start off with, we have a matrix addition equation. So you have your matrix A plus some matrix B is supposed to equal matrix C. So our goal is to find out what matrix B is. So let's take a look. As we're trying to figure out what we do in order to find out what matrix B is, it's all about your inverse operations. So we talked earlier with integers how you can do 3 plus x equals 8, and you can just do subtract 3 from both sides and you'd end up with your x equals 5 and you're done, right? And that works. Well, essentially that's okay here as well because you have those corresponding entries are being added to find out what is going to go here. So 3 plus some entry here is 8, 5 plus some entry there is 9. So you have your A times B, A plus B equals C formula. So I can just go ahead and subtract A from both sides. So it looks something like this. So subtract A on both sides. So now this is going to cancel each other out because we know that A minus A, as we talked about inverses and identities earlier, is going to equal the 0 matrix, and it'd be a 2 by 2 matrix because these are all 2 by 2s. So B is going to equal negative A plus C, or it will be equivalent to C minus A because you can switch those around for these problems. So that would look like B is equal to the matrix C, which is 8, 9, negative 3, and 4, minus matrix A, which is 3, 5, 1, and 2. So that would be equal to 5. 8 minus 3 is 5. 9 minus 5 is 4. Negative 3 minus 1 is a negative 4. And 4 minus 2 is 2. So your matrix B is equal to that 2 by 2 matrix, 5, 4, negative 4, and 2. So that helps us out to be able to find out what the solution is to a matrix addition equation. Now as we move into a matrix multiplication equation, it's slightly different. We're going to keep those same two matrices, but now we're just going to say A times B equals C. So as we work on trying to find out what that is going to look like, you have your matrix multiplication problem. So you have A times B equals C. Now the problem is that when we're working with integers, is that we would recall doing something like this. If it's 3 times x equal 8, then you can just divide by 3 on both sides. You just divide by 3, so x equals 8/3. Well, unfortunately, for matrices, there is no such thing as division. So, not for matrices, you can't use that same thought process. So it doesn't work that way. So you have to find some other way to undo this matrix A. In order to undo matrix A, what you would do is you would just have to multiply by its inverse, because we know that if you have the inverse of A times A, that's equal to the identity matrix, which is anything you multiply by the identity is going to equal itself. So now I say I sub 2 because this is a 2 by 2 matrix. And that's equivalent to no matter what order you do it in, so A times A inverse is equivalent to the identity as well. So what we're going to do is we're just going to multiply this left side by the inverse of A. Now, what we kind of do is we get a little bit lazy in our regular mathematics, or I wouldn't say called lazy, but we don't have to worry about it. You can multiply by the inverse of A on the left, and you can just say it'd be on the right side. But you can't do that for matrices because we don't know if it's going to work where you have the inverse of A times C, because that's unlikely to be equal to the C times the inverse of A, because matrix multiplication is not commutative. So you can't switch it around. You cannot. So the order in which we multiply this is extremely important. So as we have A times B on the left side, we're going to go ahead and multiply by the inverse of A on the left side because that's where A is. We're going to be able to group those together, but that means that you have to also multiply on the left for the right side of the equation. So you have the inverse of A times C. So you kind of have to sneak that inverse of A in there. We know that when you multiply this, that they're going to get canceled out and just be the identity. So the identity times B is just going to be B. And then you're going to equal the inverse of A times C. Again, the side in which you multiply your matrices does matter. So in order to get to this A, so to speak, you have to multiply by the inverse of A on the left. So that means I have to multiply by the inverse of A on the left on the other side of the equation as well, because matrix multiplication is not commutative and there is no division, so I have to be multiplying by its inverse. Now, of course, we talked about already in the previous video that to find your inverse, you do that with the calculator. So we're going to go ahead and do that now. So I have in my calculator, I have matrix A already entered in here. So matrix A, as we take a look at that, that is your 3, 5, 1, 2. And I also have matrix C entered in here as we take a look. So that's 8, 9, negative 3, 4. So all you have to do is enter exactly this on your calculator in that order. The order does matter. So you go into your matrix menu, choose matrix A. We talked about that inverse button. And then you multiply by matrix C and hit enter for your answer. So therefore, matrix B is going to be 31, negative 2, negative 17, 3, and that's the matrix that you can multiply A by on the right side to get C. So make sure that you're multiplying in the correct order and solving using your inverses.